So this kind of works like the Pew selection matrix. The big difference is it's also it helps you to compare your product with other competitors, but it goes a step beyond the Pew selection matrix. It helps you to address marketing issues as well. And you see, oftentimes in a company, engineers determine what's best in a product. It's fuel efficient, it's, it doesn't heat up too badly, or it's vibration. It's designed for minimum vibration. But how would engineers know what customers want, right? I mean, the moms and dads and grandmoms and granddads and whomever, right, are the ones who buy a car. So in quality function deployment, or the house of quality, we begin with the notion that the first step is to listen to the customer, what we call VOC. It's not, VOC normally stands for volatile organic compound. Here it stands for voice of the customer. It's VOC. So we start off with the voice of the customer and try to use their loose English language sense of what they like in a product and convert it into an engineering requirement. And then we convert the engineering requirement into a part requirement. The part requirement is transformed into a process requirement, and so on. So we make sure that the voice of the customer is transmitted throughout our planning processes. But it's a lot to take in. So as you can see here, it's a set of planning and communication routines, which is quality function deployment. It helps us to focus and coordinate skills within an organization. First to the design, then to the manufacture, and then on to marketing. Products that customers want to purchase and will continue to purchase. So the foundation of the house of the quality is that products should be designed to reflect customers' desires and tastes. It's like if you want to start a bakery here in town and you like rum cake and keep making rum cake, it may not do too well. I mean, you need to know what customers want. Do they want cupcakes or some other kind of cake? So you have to know what your customer wants, and you just cannot make what you like. And so it seems as simple as that, but it's often lost in all of this. So marketing people, design engineers, manufacturing staff must work closely together from the time a product is first conceived. Usually this group won't work together. Marketing people find their stuff, it's not faithfully passed on to design, and then from design to manufacturing it doesn't happen, and then to packaging. And so quality function deployment is a toolkit that helps everybody in the organization focus on one key thing, which is what does the customer want, what is the voice of the consumer, and make sure that all of our activities focuses on that. So the house of quality is a kind of conceptual map that provides a mean for interfunctional planning and communications. People with different functional problems and responsibilities can thrash out design priorities while referring to patterns of evidence on the house grid. Instead of each maintaining their own point, you got this grid or matrix which serves to remind everybody of what is important. Now, you can read this at length. Let me just show you what the final product. It's called a house of quality because this thing here looks like a kind of house, right, with the roof and so forth. So this is the house of quality, and in this corner, like in the Pew selection matrix, you have customer attributes, but they are stated in everyday English, not in engineering parlance, right? We are talking about an automobile and its door, right? So it says it's easy to close from outside. Sometimes you have to shove a door. Sometimes you just push and it closes. Stays open on a hill. Have you seen this happen sometimes when you open your car door and it slams, right? It's very annoying. Easy to open from the outside. Doesn't kickback. There's a lot of things, right? Doesn't leak in rain. These are your average, the doctor and the butcher and the baker and the grandma all have ideas for the product, and that's what should matter the most. And they are stated loosely in English language. So we take that and then we try to correlate it to an engineering characteristic, right? So things like energy to close the door, it's measured in kilojoules. Lock force on level ground in pounds. So these are engineering language. So we take loosely stated requirements from the consumer and then relate it to engineering, hardcore, precise engineering. Normally what we do is we go with engineering characteristics without considering the customer attribute. So this is what, and how this is filled out, the pluses indicate, the checks indicate that there's a correlation between those two, meaning between easy to close from outside and the energy required to close. If you see a cross, it means the two are not correlated. So the main thing here is that we correlate customer requirements to engineering characteristics. We then have a whole bunch of matrices. In the next matrix, we take the output from the first matrix, which is engineering characteristics, and then correlate it to part characteristics. That's the actual part design. And then we take the part characteristics and correlate them to process operations or process characteristics. Then the process characteristics are translated into production requirements. So what we do is we make sure that the voice of the customer is heard all the way through, to engineering characteristics, to product design, to process design, and then to the actual production. Now, normally what we do is we only take into account functional requirements. And the suggestion here is that we should do more than that. How about also listing some environmental requirements, like global warming potential, toxicity, energy efficiency, reusability, etc. And today the customer, people have opinions from all walks of life about the environment. And so hear from your customer what it is that they are interested in the product from an environmental standpoint also, and then correlated to engineering characteristics, and then on to product design, process design, and production. Now you not only rope in function, but you also have taken environmental considerations into account.